So as I mentioned, the T-bolts for the head and the knuckle were messed up. They were over tightened and stripped like this one here. I think that one's pretty obvious. Some of them were somewhat okay, but still had signs of stress. This one could be used in a pinch, but I'd really rather not. If you look right here, you can see this has been pulled over a little bit. It hasn't fully stripped it off, but it's close enough to say that this is nowhere near the strength it should be. So, not really good. Now, I contacted Cincinnati, the company that manufactured the machine, and you wouldn't believe the price that they wanted for these. They don't have them in stock. They said they had to custom make them, and they quoted me aerospace prices, like for something that would have been made for the space shuttle. I need 8 of these to do the full repair. They wanted over $600 a piece for each one. So I'm not going to buy from them. We're going to make it right here in house. So I did this one already. I threaded this one all the way down. The next ones I'm going to do with the thread part way, like what they did here. This one is complete though. Everything fit to spec, you know, as far as the actual fit, the usability of it. This one I've got turned down the way I want to do it, with the solid bottom, just the threads towards the end. This is just a little bit longer than the original, but I believe I have clearance on there. If not, I'll just take a grinder, grind it down a little more. And I still have to do the square on here. So you notice the hex head. All I did is I went to Martin's, which is like a discount. If you're in Maine, you know what it is. But if not, they get like closeouts from stores and things like that. Places going out of business or overstock, and they sell stuff a lot cheaper there. And one of the things they regularly have is a lot of big hardware. And I can get this a lot cheaper there if they have the sizes I want than I can at a hardware store. So I picked up 8 of these at about $1 a piece, which really, if you go to a hardware store, you're probably going to pay $3 or $4 for each one of these. These are, see, I think that's grade 5 with the 3. Someone correct me if I'm wrong. I know grade 8 has 6 on there. I'm not sure on this. I think it's grade 5. But it is hardened. I know it's hardened. So that's what this was made out of. Well, today's project, I'm going to take one of these from start to completion. Okay, so the first thing I need to do is get my pilot on the end there for the tailstock. Oh, I'm going to tighten it enough. Thought it felt like it was too loose. I really don't have to worry about mashing the threads here, because I'm going to cut those all off anyway, so I might as well give it a good snug. Alright, let's try that again. Get a little more juice here. and that should be enough to work with. So when I made this one with the threads all the way down, I used this live center, which is the one I've had almost since the time that I bought the lathe. I got this like, I don't know, a couple of months after I bought the lathe. And this has worked well for me for most stuff, but it's big and it's just a single taper down on here. And when you're trying to do threading out to the end on something small like this, it gets in the way of the threading tool, at least with the one that I have. There are a different style of threading tool. Well, let me show the one I have. So this is the one that I have. It's an insert style, but there's a lot of material out here, and with that live center, this just about comes up on the live center, and I couldn't support it. In fact, on that one I couldn't get it supported to go all the way out to the end. That wasn't suitable. So what I did after that is I bought myself another live center. This one has a step in it. It's longer and it has a narrow part up here. So this one allows you to get right up into the work up here, unless it's really, really tiny. But for this, which is 1/2 inch, I can get all the way up to the end of it and not have a clearance problem. So this solved the issue. So that second one that I showed you, this one here, I was able to do this with the live center in there and had much better results. This was all done single point, and that's what we're going to do here. I want to get some tension on here before I tighten the chuck all the way. So I set my depth. I got to pull it back on the point so I know it's centered and give it a good snug. Now we're going to lock it, put a little drive on it. I'm turning the tailstock in to put a little tension there. I'll snug it the rest of the way. Okay, so that should be good there. And first thing we're going to do here is we're going to cut these threads down. We're going to cut them off. And before I get too far, I'm going to set up a dial indicator here so that I can have my stop set the way that I want. Okay, I know I gotta at least wipe these threads out and then I'll measure. so I've got just a little over 90 thousandths to go. I'm showing 95 thousandths, but this isn't the finest cut that I'm going to do. I just switched to my smoothest cut, or the feed rate I should say. And I'll do one more measurement here right close to the end. But we've got a couple more I'm going to take now. What I need to get this down to is half an inch, 0.5 inch. So I'm going to take it down the rest of the way from the DRO. Now, one of the drawbacks of using the bolts like this that are hardened is the hardness isn't always 100% even through them, and it usually changes with depth. So it is possible as I get the final cuts in here, I may get some imperfections in here as I hit different grades of metal. I had that happen on the last one. So far this one's cutting pretty good, so maybe we luck out. They're not bad enough that they're really a problem. It just doesn't look great, but I just figured I'd mention it before we get there. And you can see I got a little bit here. I can't even feel those, but you can see there's a little something there where it's not quite as smooth as the rest. Now, part of this also could be the depth of cut. I was cutting 20 thou a pass before. The last one here was 15, and the next one's going to be approximately 15. so that should put me on it right there. So the next thing I want to do before I start threading is I want to bring the little step up here. We're going to bring it right up so that this is all flush, one flat surface on here. So we're going to face that down. And I'm just going to do this with a manual feed on it. Okay. I got to make sure I got to clear the jaws on the chuck. Looks like it cut to the edge, but there's a little line right here. I don't know if it was bouncing from the chatter, hitting the corners. I'm going to push that just a tiny bit more. I've only moved that about a thou, just enough to try and clean that up. Okay, that cleaned it up nice. So now I've got a good flat surface, because this is going to be the back of the T-nut once I get that squared off. So that needs to be pretty good because it mates against the back of the T-slot in the head. Okay, so getting everything lined up, I'm going to do the straight shank here. The threads start at 1.1 inch. And I'm going to do my groove at the top of the threads, 0.1. So I'll have 1 inch of shank, start the groove, and then 1.1 will be the threads out. So I'm just eyeballing the point of the tip to the back surface of this, and using that as my reference to start, and that's where I zero the DRO out. So now I'm going to come back and I'm going to come all the way down here, and I'm going to move in till I touch off. Okay, so that gives me my zero for my cross slide. My positioning of the threads and the groove, I want that to be referenced to when the threads are cut all the way in. And our compound, we're cutting in here 30 degrees in. So I'm going to consider this the touch off that I've done here as being the position for the cross slide when it's all the way in. So I'm going to punch in the number that I'm going to hit. Then I'm going to cut my grooves here with my distance out from that reference point. We'll come back to 0 and start cutting the threads and then work my way back to the number that we're supposed to hit. So next I need to set my dial indicator for the stop point. I'm going to back this out a little bit, go up to my stop point via the DRO. Okay, so now I have my stop point, and I'm going to move back to the beginning, and we're going to move the cross slide into 0. And eventually I got to make a lock for my cross slide. The one that's factory is covered up by the DRO scale, so it's not usable. But there is a way to do one from the other side. I just haven't gotten around to it. So in the meantime, I have to really pay attention and make sure that the 0 stays on 0. I gotta make sure I have the right gear ratio for the threading feed, and then I'll advance my combination. I'll probably take, I don't know, the first pass I'll probably take 20 thou. We'll see how that does. And as I go in, I may cut that back to 10 thou. Okay, so this is a 1/2 inch thread, National Fine, so 20 threads per inch. Okay, and I already know the right gears are in there. Just got all my knobs set where they're supposed to be. Okay, let's advance the combination here. And that looks better. Just a little short of what I needed there. Okay, we're getting near the end. They get progressively harder as you get further in because you're cutting more surface. So now I'm only going about 5 thou in. Probably could do this in one pass, but I'm going to split it in two. Okay, so this should be the last cut. I may do a cleanup depending on how it looks, but this should be the final dimension though. Okay, so I think that should do it there. We'll check this in just a minute. So it's a little bit gritty. This is hardened steel. There's probably a few little burrs in there that aren't cleaned out yet. But it fits good. With a couple passes back and forth, this should clean up nice and it'll run smooth after that. In fact, just going back there, that feels better. And I want this to be a snug fit. I don't want a loose fit on this. So that's working there. I mean, it doesn't spin completely free, but I can turn it by hand at this point. Okay, so that completes the threading operation. The only thing I have left on the lathe now is I need to change out my chuck. I'm going to go to my collet chuck and we're going to face the other side of this. I got to set the dimension on that and then I'm ready to mill it square instead of a hex on here. Okay, so when I faced these off on the lathe, some of these came out really nice, and a few of the first couple I did, my insert on the lathe tool was not that sharp. I ended up changing it part way through. So I have a few, I don't know if you can see it, there's quite a bit of burrs on that. I'm going to have to clean that up a little just because it's going to make it difficult to get my center on here, because I want to just touch that. So if you look at this one, it's nice and clean. This is one of the ones that came out good. This first one that I'm going to do here really got the worst of it. It was probably the last one I did with that bad insert. So I'm just going to take this and give it a quick grind right on the corner there. I just went very lightly just to take the corner off. Don't really want to change the profile there. Okay, so I'm using the do-it-yourself mini mill that I built because the Cincinnati, I don't have the overarm operating, obviously. So this is still functional and it will do this job. I've already used it for a couple. Actually, before I do that, I want to verify that I still have this at least reasonably straight on here. I've dialed it in before. Actually, it's going to change because I moved the table here. May work out alright because actually rotating the table on the column won't affect that. So each tick on here is 1/100th of a millimeter. So that was about 5/100ths of a millimeter from one side to the other. I mean, if it was something that really had to be precision, I'd try and tune it in better. But this is a bit of a pain to get straight in this setup. And I'm going to call that good enough for what this is. Okay, so now I've got to find the center on this. That should bring me to center on 0. Okay, that looks good. So now I have to find center for my X. So now I got center, left, and right. Okay, so the calculations I did before that I made the others off of, I go 16.2 millimeters to either side of the center. So we're going to cut a flat here and a flat on the other side, and these two flats going this way will get pulled in a little bit. So I think I'm going to do this in a couple of passes. I don't want to take that all at once. That should complete that side. The machine will cut fast enough, but I don't want to knock this out of position. so now I'm going to take 2 ends down. Actually, hold on. Okay, so I stopped for a minute here. When I got a good look at this, it was apparent that this had indeed moved. I didn't have it tightened up, and I was probably pushing a little too hard for the clamping force that I had. So this took a little bit to get it recentered, but I've got it recentered now. I've got it clamped down good. I'm going to keep checking that as I go. I just took one pass here. I got one more to bring it down to the 16.2, and then we'll get this finished up on this side. I'm going to take it a little slower this time. I got to move down.
So I was cutting fairly slow here after that part had shifted. I'm going to skip ahead at this point to the last bolt, and we're going to really pick up the pace here.
So that should do that side. The last ones I showed I was cutting, I was only cutting at 3,000, about 3,000 RPM. Now since then I changed the belts on this so I can utilize the highest speeds on here. And I just cut one. Unfortunately, I was out of memory on the camera, so I didn't get to film that one. I got one left to do here. This is the very last one. I'm now cutting at 5,500 RPM, quite a bit faster, and it made a big difference in what I could do for feed rate. So I'm going to film this so you can see what this machine can really do running at full speed here. So I've already got this dialed in. I've got my zeros, and I'm ready to start cutting here. I gotta lower this. I set this a little lower than the other one, so I gotta drop my spindle a little here. Through that again real quick. Okay, so that completes that, except for the chamfering, and that went way faster than what I did before at 3,000 RPM. So this was 5,500 RPM. Right now with the belts I'm using, that's the max it goes. I don't really have the right ones in here. With the original belts that go to this machine, it will actually top about 6,000. So this concludes this project. All the T-bolts are now made. Next step, we have to deal with that shaft, and we'll be reassembling and putting these bolts to use to reassemble everything. Thanks for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.